Okay, I just wanted to go over example 6 from this section 4.1 through 4.3 practice problems. It's actually much easier than some of the problems we worked out earlier in this note sheet, or this practice set, because when they give you the coordinates of a point that is on the terminal side of an angle, there's no ambiguity. There's no questioning about where that point is going to be. So we're talking, I drew a little coordinate plane over here, and we've got a point that's -2, 5, which would be left 2 units and up 5 units. So to be hanging out somewhere up here. So if I go ahead and put some tick marks here, not that it's really all that necessary to have the tick marks, but more just an idea of where that point would be, sitting up here at -2, 5. That means in order to get there, we went left 2 and up 5. Now, if we think about our terminal side of our angle, remember we've been talking about in class where this angle could be kind of, coming out here, 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 and as we move all the way around the circle, we could think about that angle having rotated to this position so that the terminal side goes through that point. Now, the angle that got us there is, identified by that little arrow in that theta. However, what's important is this reference angle that's in here, and I'll put a theta with a little subscripted r to indicate that that's our reference angle. Now, we were told that the point is at -2, 5, which means necessarily we went left 2 and up 5. And in order to determine the 6 trig ratios, all we have to do is get this third side, the hypotenuse, and figure out what that is. And of course, to get that third side, all we have to do is use Pythag. So we'll go do that. Off here on the side, that -2 squared plus 5 squared equals our hypotenuse squared. So that's 4 plus 25, which is 29, which is our hypotenuse squared. So our hypotenuse is root 29. Now notice I disregarded the plus or minus there. Because it's the hypotenuse, we talked in class about how that's always going to be a positive quantity. So there's the 3 sides of our triangle. Left 2, up 5, and the hypotenuse is root 29. So in order to do the 6 trig ratios, we just have to list them: the sine of our angle, the cosine of our angle, and the tangent of our angle, and their reciprocals, the cosecant, the secant, and the cotangent. And all we have to do is remember SOHCAHTOA to say that the sine of that angle is the opposite, which is 5 over the hypotenuse root 29. So here we go with 5 over root 29. If we want to fix that, it's going to turn out to be 5 root 29 over 29. To think of its reciprocal, though, don't think about this rationalized version. Go back to just the original one and reciprocate that, and we just get root 29 over 5 for the cosine. We are thinking about the adjacent side and the hypotenuse, so -2 over root 29, -2 over root 29, and again, rationalizing that, we get -2 root 29 over 29, and its reciprocal, of course, would just be negative root 29 over 2, and lastly, the tangent is simply the opposite over the adjacent, so it's 5 over -2, so -5/2, and the cotangent, of course, would be -2/5. So these problems are considerably easier because there's no reasoning about what quadrant we need to be in when they literally tell you that the terminal side contains the point -2, 5. Now, it's important to realize this is not a unit situation where like it's on the unit circle because our hypotenuse, our radius, is not 1. But it really doesn't matter because all that we're focusing on is these ratios of side lengths. So those are very typical problems in math, say math analysis, pre-calc, algebra 2 trig, but they're pretty straightforward when it comes to reasoning them through. The other thing I just wanted to mention, we have some more examples here where we're going to try to find particular trig ratios for angles that are going to be found using special angles as their reference angle. So in other words, angles that have a reference angle of pi over 6 or pi over 4 or pi over 3, or they're going to be quadrantal angles. And I'm going to leave these for you students to take care of, but I wanted to do one that leaves us with a quadrantal angle. -77 pi over 2, for example. This is a kind of a funky one, so maybe we'll take a look at that guy and reason our way through that. So I'm going to come over here and draw my coordinate plane. And the first thing we have to do is think about where the heck is the angle negative 77 pi over 2 radians. So you do a little arithmetic and say that negative 77 over 2, that means we're taking 2 into 77. 2 goes into 7 3 times, and we're left with 17. 2 goes into 17 8 times, with 1 left over. So this is 38.5 pi in the negative direction. So negative 77 pi, negative 77 over 2 pi is the same as negative 38.5 pi radians. So 38 pi, whether it's positive or negative, that's an even multiple of pi. Every even multiple of pi is just going to get you back to where you started. So negative 38 pi is just, 19 times around the circle backwards. I'm not going to sit here and draw 19 swirlies going around, but you can recognize that it's going to land you there. But then we have this extra half a pi that's going to take you down here. So that's the kind of reasoning you're going to need to use when you decide on where these angles lie. So negative 38.5 pi radians, or negative 77 over 2 pi radians, is going to get you down here. Now, notice, in all these other problems that we had done in the earlier examples, we always found ourselves down in one of the quadrants, and we said, okay, well, maybe we land in the third quadrant, and we would draw a perpendicular back to the x-axis. We would label two of our sides. Let's say maybe this was negative 3 and this was negative 4. We do Pythag to find out that's 5, and we were ready to go. Well, with our angle landing us here on the negative y-axis, there's no triangle. We can't draw a perpendicular back to the x-axis because we already have one. So all we have to do in these situations is just think of the coordinates of that point, and this particular one would be 0, negative 1. If we were over here, it would be 1, 0. If we landed on the top, it would be 0, 1. And over here on the left, of course, it's negative 1, 0. Remembering that it's cosine that goes with our x and the sine that goes with our y, we're ready to answer any question that comes up. So for the secant of negative 77 pi over 2, which is what we're after, all we have to think about is the reciprocal of the cosine of negative 77 pi over 2. Well, the cosine is 0. So if you think about 0 as a fraction, it's 0 over 1. Well, when you reciprocate that, you get 1 over 0. Ruh-roh, you've just divided by 0, and that's a serious issue. Whenever we have a 0 in the denominator, we get a quantity that's undefined. So I may write 1 over 0 here, but I'm not going to leave it like that, and you should never either, because you want to communicate to the reader that you understand that 1 divided by 0 is an undefined quantity. So the secant of negative 77 pi over 2 is undefined. Do not leave it with a 0 in the denominator, because again, if I'm grading this and you leave it like that, I don't know if you understand that 1 over 0 is undefined or not. So you need to write out the word undefined or put UND or something like that to tell me that you understand that. So basically, any of these angles that have a quadrantal angle, like the negative 155 pi, that's going to put you over here. An odd multiple of pi is going to put you over here on the x-axis. You have a potential with cosecants, secants, cotangents, and tangents of having a 0 in your denominator. For example, right here, your cosine is 0, and so the secant would be undefined. At this point here, your sine is 0, so your cosecant would be undefined. For example, if you were thinking about the tangent of an angle down here, it's the sine over the cosine. Well, negative 1 over 0 is an undefined quantity. So there are lots of ways to get a ratio that's undefined when you're talking about cosecants, secants, tangents, and cotangents. Having said that, you will never have an undefined quantity with cosines and sines. They just vary between numbers between 0, they go up to 1, they go down to negative 1, and they come back to 0. So those values are always going to be numbers between negative 1 and 1. So hopefully you can handle the rest of these examples and the other ones from the other note sheets that we started in class, and you'll be good to go.